So I am giving the presentation. This is my third one on the Linux Lustre client. So 5 years ago, EMC pushed up Lustre to the Linux kernel and abandoned it. And for several years, it just decayed. So some efforts have been put in to revive that and bring it together. And actually, we've made a lot of huge strides, especially around the Lustre 2.11 release and what's going on recently upstream. So I titled this Sanity Prevails because it's starting to actually come together. So why is this really important? And the reason it's important is because we're living in a new world. So I know at my place of employment, the support matrix is expanded. We have Power PC machines, we have ARM machines, our normal Cray machines. So we have this diverse environment that's starting to come to be. We have even one system on campus that's a Ubuntu machine. So the vendor said, our administrator said, we hate Ubuntu, and the vendor said, you're going to live with it, or you're going to get any support. So they said, okay, we'll stay with Ubuntu. So actually, I've been working on that as well. So some of the nice things that have come is we have, as Peter pointed out, Ubuntu 16 support for clients. And actually, the little dirty secret is actually you could, if you really, really want to try it, server support, even including LDiscS for Ubuntu 16. Why is Ubuntu important? Number one, it tracks really closely to the latest Linux kernel. So any issues we see with the upstream client is now appearing in our clusters. And also the same with the ARM and Power 8s. Because of their platforms, they require newer kernels as well. So we're starting to see an overlap in all the issues in the upstream client and in the ARMs and Power 8s and the Ubuntu systems. The other reason Ubuntu is very important, if Lustre ever wants to get into the cloud market, 50% of the cloud market is Ubuntu. That is the reality. RHEL is not a major player there. And with all these systems, we've been in major bug squashing mode. So in all these upstream, ARM, we have ARM and Power 8 now works with the latest in the 2.12 branch, right out of the box. You don't have to do any special configuration or loops. Well, okay, if you have Lustre 2.10 server backends, you have to do a weird thing to make it work with Power 8 or ARM. So that's the nice thing is that all these, we have this incredibly diverse environment. So what are the issues being addressed? So basically, because we have the upstream client and we have the OpenSFS branch, there's a lot of back and forth going on. So we have to, but a lot of the efforts, a lot of the bugs and issues that make the experience bad is being actually addressed on the Intel branch. And the reason for that is because it's just the limited manpower. There's just not enough of us to do that kind of work. That's the only thing. And also the upstream client only has limited testing. So it's just basically Sanity and Racer most of the time. We manually do these tests. So who's involved in this project? So myself, I do a lot of the bug fixes. I deal with all the issues and all the breakage up there. Neil Brown from SUSE has become involved. SUSE has expressed a strong interest in the upstream client. And Doug Ulrich from Cray he's also stepped forward to want to help with the InfiniBand layer and fixing all those issues and LNet upstream. And of course, Andreas Delger has been doing reviews, and actually Patrick Farrell has also stepped in from time to time to do reviews on some of the important changes. So thank you for doing that effort, and it's nice to see I'm not alone anymore. And for a while I left Andreas alone because I was busy with cycles. Sorry, Andreas. And as I said, the big issue is now we're seeing the same issues rise on both these platforms. So what have been the issues? So this is the progress we've made. So one of the progress from last LUG is we have completed the UAPI headers. So there was all this kind of kernel stuff and userland headers and vice versa. That has all been straightened out. That is all clean. We have actually, and it's been submitted upstream as well to master. So those issues are gone. So when you see your packaging system, you're going to see it. You're going to say, wow, it's different. And because of that, I was able to clean up our long-standing issues with packaging. So our packaging system was just really horrendous. No dependencies on external packages and things like that. And because of this, we were able to clean up the libraries. The libraries are simplified. So instead of 6 or 7 libraries like we used to have, there's just 2. LNet config.so and liblustre API. That's it. It's much cleaner now. So, and the reason some of this work was done is because we're not far away from the ability to build our utilities against the upstream client. That is the next step. So hopefully we'll start doing this during the 2.12 cycle. You'll be able to do configure disable modules, and voila, it will grab and build your tools against the upstream client. So that's one of the goals. So some of the things that have also been addressed is xHatter and ACL support was totally botched. The behavior in older kernels worked, but in newer kernels, there were just all these subtleties. With Ubuntu support coming up, John Hammond looked at it and said, oh, this is what's broken. And I sat down, and then I looked at the upstream client, and I looked at it, and then, most of it was addressed, but there were other bugs because there is no quality control in the upstream client. If you submit a patch, it will land, no matter what it is. It's just the way it works. That's how it's managed, the staging tree. It's sad, but it's true. So I actually found the bug that was breaking stuff there. So it's fixed. I submitted the patches upstream, and actually Dan Carpenter found a bug in that patch, so now that has been addressed, and that's going to land to 2.12. That's the last bug. The other thing that's missing that was addressed is the Mellanox OFED stack. That was really, really busted to work with Lustre. So it took a lot of rework and stuff. And actually, it's much easier to config. So when you look to do your YAML config now, so you'll see things like concurrent send in that and map on demand. You can send them, you can set those fields all you want because it's auto-negotiated and you don't have to do anything. So that actually simplifies life. So the other thing that was done is because my ORNL has a very strong interest in the ARM platform. We resolved with the InfiniBand fixes the ability to use 64K page systems like the Power 8 and ARM. That would break systems, so anyone who has an ARM system and try to set up, you know that you got all these I/O errors and times outs with bulk transfers. That's all work. That's all fixed, and it works out of the box. So also, and as part of, and related with that is, of course, Doug is working with me to actually push all these fixes upstream. So there's actually more. So we did a lot of work, and most of this work is almost completed. So one of the things that's changed upstream is the 2038 bug. So they went through upstream and they changed a whole bunch of stuff. I looked at it, and a lot of it was wrong. So on master, we did it. This is one of those things that looks like a very simple fix, but it's so easy to break everything. It was unbelievably crazy. So some of the things that have been addressed is we were using Jiffies for everything, even sending it over the wire. So Jiffies is configurable. So that means that your nodes could do 350 ticks per cycle or 1,000. So there could be these weird corner cases where things don't actually address right. When you called schedule timeout, it would take 10 times long if you set it 100 versus 1,000. So the behaviors were inconsistent. So we actually removed that. One of the most atrocious things, which was brought up last year, was LRU max age, which everybody looked at, and people were like, why is it 60 years for the timeout for the cache? And I said, no, that's not in seconds. And I said, and they looked and they said, what is it in? Is it in milliseconds? And I said, no, it's in Jiffies. And they were like, wow, why would you do that? And so I went in and I totally ripped out the Jiffies use. And it still reports because Jiffies are normally 1,000 ticks. So it will report in milliseconds. So you got to keep that in mind. But when you configure it, you can actually set the LRU in seconds. You could say equals 10s, and it'll be seconds, and it'll translate it internally to the milliseconds. So that has been fixed. So we went, and I've gone through the code, and I've ripped out all the jiffies, replaced them with k-time if we needed nanosecond precision, or time 64, which is in seconds. So now we have very little use. Only schedule timeout is the only thing, and it's just the kernel doesn't support high-resolution timer scheduling. So there's no way to get around that. But that is very minimized now. So the other thing that's very important too is that jiffies is kind of wonky on tickless systems. So this is one of the systems that you can actually turn off the RTC clock and use a high-resolution timer. So that actually changes the behavior of the kernel a lot and how it's managed. And we wanted to support that kind of environment, so it is very difficult to understand the scheduler in a tickless environment because HZ is 0 in that case. And that really busts Lustre. But the good news is there's only like 3 patches outstanding. 1 is ready to land. So that work will finish up in the next couple of weeks. The next thing that we did, which was a requirement upstream, was to move everything on a proc. So we have enabled SysFS support and DebugFS support. So all your proc stuff, please don't use proc directly because you're going to find out it's disappeared. In fact, I saw somebody post on Discuss, hey, where did my devices file go? And I said, you're not supposed to do it that way. So there are also changes in this behavior that impact users. So one of the things is we have been working out all the issues on master. So upstream, the SysFS stuff is actually pretty borked, actually. It doesn't work properly. In fact, it prevents you from unmounting Lustre cleanly and things like that. It just was not done right, and that's because the tools didn't support those SysFS when the patches were created. So they said, please port and do it now, and we couldn't test it. So patches were just thrown in there, and they didn't work. So there was not much you could do about that. But now that's all being addressed. So one of the issues we did see, which was reported, was that debugfs is root access only. So some time ago, it used to be that you could access it, and it's mainly for just debugging stuff. But the problem is that there was a lot of crap in debugfs. It's actually the dumpster FS. I always thought of it because people just throw stuff in there, and it shouldn't really be in there. And we kind of did the same thing upstream, but. So the problem is they said, oh, we're going to only allow root because people can do nasty, ugly things to their systems. So this causes breakage for scripts in that, because a lot of things are done without using root. So we have been looking to address those issues, and we had a discussion yesterday at Developers Day about how to approach the few pieces that have this issue. Another piece of work is the setting of the permanent parameters with -p. That was introduced in 2.5. That has never worked completely properly. Now it works for everything except for the secure portal RPC stuff. That stuff is very special in its own way. So that's going to take extra work, but that's the only thing. So failover NIDs you can use with this. You can do pretty much all the other stuff. Quotas, all that stuff was moved over. And one of the nice benefits that came out, and I will talk about that, is UDEV events. So one of the nice things going to SysFS is actually we have the ability to send events from kernel space to user space, to systemd. And it can actually report and register it. We're seeing the birth of health monitoring. So this is a quite exciting thing that popped out of this work, actually. And lastly is the tracepoint work. So I experimented with tracepoint last year, and it was reviewed, and Intel did not like it. They just said, perf support will never happen. Please do not do this on master, and don't do it upstream. They had issues with it, and there's some discussions going on about that still, the pros and cons of each of the debugging systems and that. So hopefully someday that will be resolved. So I wanted to talk about the impact now that we're becoming closer in sync, and also because of the overlap with the 2 branches. So the last thing is we still do. The only thing that's really the two things that I notice that people, when they push patches, I wish they wouldn't do. Please, one thing is the comparisons with null pointers. That is the one thing that they are strict about. Comparisons of integer values to some zeros or RC equals 0, that they don't care. But this is, for some reason, they're hung up on it. Dan Carpenter describes it as a double negative, so he claims it hurts his mind when he looks at it, and that's why they don't allow it. The other thing I notice is everybody uses U__U64 in their code. That is for user LAN interfaces. That's for UAPI headers and stuff, and structures that come from user space. Do not use them anymore. Those annoy people. Please use U64 internally and U32. Outside of that, pretty much everything that's being pushed is pretty standardized now. Also, please, I beg for the life, when you do time stuff, consider not using int for time handling. Int is 32 bits, and these are 64-bit values. Use time 64 and time t. It's very easy when you're working with 64-bit and 32-bit, adding, subtracting, and doing numeric operations to screw it up, and then you're going to see negative time values or times way in the future, and you'll be like, why is that broken? So please consider, and that way when people review the code too, they'll say, oh, that's used for time. Time 64_t is for time. If you have int and some reply delay, you're going to look at it and, what is that? What does it mean? Is it seconds? Is it supposed to be nanoseconds? Don't know. So please. And so don't use jiffies anymore. Please don't use jiffies. I beg you. That was really painful to get out, except for scheduled timeouts. Another thing is, and I see this yesterday, no more proc. Please, no more proc entries, because I'm going to remove them on you if you do that. And of course, we have new proposed features. And also another thing is when we're getting to the point where it's coming to the day when vendors like DDN and stuff make features. We're going to have to start getting in the habit of approaching the VFS maintainers and discussing with them designs and things like that. They will have their strong opinions. Please send your employees who have strong stomachs, because they're not nice. I will be honest with you. If anyone reads the mailing list and sees the abuse I take, and you're probably thinking, how does he deal with that? I don't have the energy to care, but that's how I deal with that. So impact on administration, like I said, there's new API headers. So if you look in user include Linux Lustre, you'll actually see there, and LNet, that's where your headers are. So we do have wrappers in user include Lustre. So most of them are thin wrappers. There are a couple headers that are true headers that people will use. And if you try to use those headers in there that are wrappers, it will print out a warning and say, hey, you should be using these headers. You can still build, but your users will see that. So when this occurs, you'll go, oh, I should move those over to that header. So the other thing is you can now use set cuddle param, the permanent parameter setting, with UDEV rules. So I give you an example here, and this is the classic one that actually is the default one for setting parameters. So when you do your set param on your MGS server, the event will be, the change information is sent down to your clients, and it'll be generated and send a event to systemd, and it'll actually run these parsing rules. So as you can see, so there's information in these events that are being sent out that you can parse. Now the beauty of this is before we used an upcall, and the upcall was always lcuddle. There was no flexibility. So now you as administrators can control what you do with your tunables. You can filter, you can control, you can run your command. If you don't have to run lcuddle, you can. It's a much more powerful resource. You can also tune your Lustre file system. So one of the things coming out, this one I kind of threw together because I'm testing how this can be done better. But in theory, you could use UDEV rules to configure your Lustre file system for your tunables. So normally when Lustre starts up, there's these UDEV events are being sent from all the different subcomponents as add, and you can run and tune what you like. And there's filters you can use, so if you want to use different tunables. So everything would go into your Etsy udev rules.d file. There would be, there's 99 Lustre, you can create your own. So tunables is very easy. One of the things I saw requested is you would always wanted to know what all the tunables are, right? You look at the tunables and say, what are they? What are their values? You can use udev admin. That's the command, just run it on top. Lo and behold, you see all your attributes, you see all the values, and you go, wow, it's easy. I can filter, I can sort. So these are some of the nice things that can be done now. And I saw this was one of the requests actually on the survey list, or like, what would you like as a feature? Well, you have it. That will be in Lustre 2.12. The other thing that's coming out of this is because we can send events, is actually the ability of doing health monitoring. So these events come out. So one of the things we were talking about is like, I was working on is client state changes. So like say your client goes into recovery and it gets evicted, you can run a udev command and collect the logs. So it will tell you when the import is closed, it opens, it changes state. It's a very nice feature. And this is actually, I've been working closely with Intel, and we've been discussing this for the LNet health stuff. You'll be able to monitor your LNet networks. If a peer goes away, or if your network is timing out, you can actually collect these events through udev and send it to Splunk. Very nice, isn't it? Something that was always missing. So since the last year, so that's the changes coming to you, and to be aware that you'll need udev rules when you set up your systems now, starting with Lustre 2.10, and going forward, there will be a lot more things you'll be able to do in 2.12 if you plan to run that. So what's the progress since then going on in Upstream? Well, SUSE has expressed a strong interest, as they put it. They've become involved in the development heavily, actually. And this is one of the nice things, and a lot of progress is being made in that way. We updated the to-do file, so there's a huge list of things that would be to make the Lustre client pretty good state, actually, so people would use it. All those things that they gripe about with the check patch and style changes are pretty much done. In fact, I've seen in the last 6 months maybe 2 or 3 style changes in total. So those days are behind us pretty much. And we keep resolving bugs. I've been chipping away at that. The technical debt is being eliminated. So we've seen things for like the L-wait event being replaced with work queues. So this should be able to allow better scaling. We've seen the reduction of thread uses, kernel thread use in the upstream client. And this work is also being ported to master. libcfs is almost gone. And lastly, the thing that shocked me, and I didn't think that Greg would be as tolerant, but actually there's stuff that Lustre has carried for years that's being integrated into the Linux kernel for standard usage. So that's actually a big win, actually, in that case. So we're still at a pre-2.9 because it's been in bug fixing mode. So feature-wise, it's at about that level. There's just like 10 patches missing to make it official 2.9. So what's left? I'm still resolving the sysfs and debugfs issues. That is the last major hurdle, which I'm addressing on the OpenSFS branch. The other one is we use linked lists as arguments for things. This is LNet self-test and node map. This is like really awful to do. There's a lot of security implications to doing this and stuff. So we're considering reworking that code. In fact, actually, we should probably upstream just delete the self-test module and submit a new one that's completely rewritten. That's much better than what we have now. So I've talked to Amir about that, and it's a perfect candidate to use YAML with LNet self-test and things like that. So, and we can make it forward-facing, the same as you always have, but internally we can make it very different. We have a lot of ioctls from like Lustre 1.2 and 4 still in there. And the ioctls, the way they work in those older things is it's very in direction. There's like one device file that all the modules pour to for their ioctl calls, and it's very difficult to follow that code and all kinds of things, and it's just a mess. And we can clean up and remove a lot of those ioctls. We have SysFS and other things to fix that up. So we'll be cleaning it up. The other thing that has been requested, Alviro has requested this especially for LNet, is to move to the Netlink API. So the Netlink API has certain advantages, which is nice. One is it's very I/O forwarding friendly. So if you have to send stuff across the network, that's. And the second thing is unlike ioctls you tend to, if you change the ioctls, you have to create a whole new one. Like setstripe, we have new setstripe in our code, a whole new ioctl, but with Netlink, you can just do versioning and change the size of the packet being sent over Netlink without requesting a whole new ioctl and setting it up or updating your tools. You just have to test what the packet's sending and see what version it is. And of course, we have macro cleanup to do and no function pointer rejection. So there's a lot of issues with that, which we had discussions yesterday about what to do and how to address that. And of course, we have fixes always to port from master. So the conclusion is there's a lot stronger interest, actually. First time we've had an outside player look at this and actually work on this. So a lot of the major changes are completed. So my days of stomping on master are coming to an end. So those 30,000 lines of change will dwindle down a lot probably after Lustre 2.12 because many of these issues will be done. And then of course long-standing bugs that we're starting to resolve those. And of course we have this better integration with the Linux kernel. So those are the progresses we've made. So actually, it looks like there's light at the end of the tunnel for this. It's been a long slog. And actually, this is an interesting point. So I know that most people don't want to send patches, and that's probably because of the responses you might get and not feel happy about yourself after you receive them. So I can understand that. I take the abuse. But what would be nice is we're getting to the phase as we progress, especially once we leave staging. But even now, is if anyone wants to actually cut their throat on this, try the upstream client. If you have test clusters of better size, I mean, the biggest I could probably get my hands on is 80 nodes. But if anybody has a few hundred nodes in a test cluster and want to give this a spin, I can easily help them and see how it works for them. And if you have users, I mean, this is probably the biggest thing, is to figure out what is really broken. That can be your contribution. All right, that is it.
Our speaker, James.